Gonna be at a yard sale. Amanda sold paperback books for 50 cents each and hardcover books for $2 each. Okay, she sold a total of 18 books for $19.50. How many of each type of book did she sell, right? Though everything is always in a question. So they're saying how many, implying we don't know, of each type. Each implies that there's more than one of something happening. So each type of book. And then you have to think to yourself, all right, so what kind of books were there then? Okay, well, there was the paperback book. Okay, so we're going to use a let statement here. Let x, okay, equal. Now, we're not going to just write paperback books. Is it the cost of them, how they look, how they feel, the number of them? So, again, you could just look back at the last sentence of the question. It'll tell you how many of each type. So, this is going to be how many, or the number of paperback books. Paperback books. And the other one is let y equal the number of, in this case, they were hardcover books. Hardcover books. Okay. So now it says we need to figure this out. So they didn't give us anything. There's like nothing. We have to just be on our own for this one. All right. Well, let's see. We have two variables. Okay. So we have two variables. In addition to that, they gave us two other pieces of information, and this is what's really going to be important, is that they gave us the total number of books, as well as the total, I'm going to circle that again, right, the total cost for both of them. So they gave us two totals. Okay, so they gave us two totals. Now to me that means two equations, right? And when you write your equations, they have to be about specific units. So in this case, they gave us the total number of books. So I'm gonna go ahead and just write the total books. So let's see, how do I even think about this? Okay, I'm gonna put an equal sign, put two equal signs, right? And this whole equation here, this is just going to be about books, just about books. That's it. And I'm gonna actually erase this piece off. I don't know how, if I'll have enough space, and then this will just be about money. Okay, so to make the money one, I think that's a little easier because they told us exactly how much each one was. They said it was 50 cents for each paperback and $2 for each hardcover. So it's 50 cents for each paperback. Now, instead of writing paperback, okay, we don't have to do that anymore. We can actually go up and we define a variable to use every time we want to mention paper books. So 50 cents plus $2, okay, for every hardcover, and the total cost is $19.50. Okay, but again, just really make sure that you understand, like, this was about money, because money plus money, $2.50, right, must equal money. So they're all the same consistency. For books now, all right, we're going to start with the total, and the total is that we know there was a total of 18 books. Now, if there's a total of 18 books, think of like a shelf, and on this particular shelf, what types of books are there? Okay, well, there's only paperback and there's only hardcover. All right, so X represents the number of paperbacks. We have no idea what that is, but we do know that when you add up the total number of paperbacks and the total number of hardcovers, you should have 18 of them. So we have a system of equations, right? We have two equations. There we go. Now you can use anything you want to solve it. I'm going to use elimination just because I'm a fan of elimination. So to use elimination, we have to choose a variable. So you can either eliminate the x's, okay? I'm going to go ahead and just place a 1 here to make this easier, or you can eliminate the y's. I'm going to choose to eliminate the y's because I know that to eliminate something, okay, so to eliminate, right, we need those two things. And what are those two things? We need that they need to be not positive, sorry about that. Yep, they need to be the same numbers and they need to be opposite signs. So I could make them both to be 50 cents, but I mean, that's dealing with decimals. I don't want to deal with decimals or fractions, so I'm going to deal with the whole numbers. So I'm just going to put a 1 next to every variable. And my LCM here, okay, if you were to count by ones and you would count by twos, 2 would be the most optimal number. So the way that we get this whole, oops, okay, awesome. There we go. Okay, the way that we get this to be a 2 is that we got to multiply this equation by a 2. Okay, and then the same thing on the bottom here. Okay, we want to get this y variable here to be a 2 in the front, which we already have. So we'll just multiply by 1. Okay, so that takes care of the same numbers. Now, will they have opposite signs? Well, 2 times 1 is a positive 2. 1 times 2 is also a positive 2. So they wouldn't have opposite signs, but we can change that just by simply adding a negative. Right? If we go ahead and distribute this, and I'll distribute this in a different color, bam, negative 2 times 1 is going to be negative 2x. Negative 2 times positive 1 is negative 2y. And then negative 2 times 18 is negative 36. If you were to distribute the bottom, okay, we only left with 0.50x. 1 times 2y will give us 2y, and then 1 times 1950 is going to give us positive 1950. Right? From here, if you remember, we're going to add. Okay, we're going to add downwards. So negative 2 plus 0.50 is negative 1.50. Negative 2 and positive 2, these cancel out. That's the whole purpose of this. And then I have no idea what this is. So I feel like it might be 1650, but I don't know. I don't want to give you the wrong answer. So let's see, 36 plus 1950 is negative 1650. All right, so negative 1650. Okay, and just continue doing this. So divide both sides by 150. Divide both sides by 150. And we're gonna get 150. Oops, JK. I definitely put that in wrong. This calculator sucks. 1650 divided by 150 is 11. Okay, so x is 11. All right, so you should always pause and just be like, all right, what does this even like mean? Because we're not dealing with like regular equations now, we're dealing with word problems. So like, what does 11 mean? Well, if you go back, it's 11 is equal to x, and then all the way at the top here, we had x was equal to number of paperback books. So that means that we sold 11 paperback books. Now, we want to know each type of book. So we need to choose an equation here. Always choose the easiest one, right? Definitely not going to choose this one. We'll choose the first one. That was x plus y equals 18. And we're going to substitute that x right there with 11. Keep everything else the same because we don't know what y is yet. And if we continue to solve for y, we will discover that y is equal to 7. So they sold 11 paperback and 7 hardcovers. Right? Not so bad. I don't think so. I think it's cool. All right, I think that's it for this one. I'll pause this one and make a new one for a different question.